Assalamu alaikum girls. I am Shamsunisa from Royal Degree College, Chemistry Department. As we are talking about second unit Organic Chemistry, Chapter 2, Heterocyclic Compounds. In that, today we are going to study about nucleophilic substitution in pyridine, CHICHIBABIN reaction, alkylation and ARYLATION in pyridine, electrophilic reaction in pyridine. Nucleophilic substitution in pyridine. Nucleophilic substitution takes place in pyridine at second or fourth position. Here you can see the reaction. We are taking the pyridine. In that we are adding the nucleophile. See, in case of the pyridine, where the nitrogen is present, that is the first position, and this is the second position. Here you can represent one hydrogen outside the ring with the single bond. So what will happen here, as the double bond is present, one of the bond it is shifted towards the nitrogen. So on nitrogen we can represent the negative charge because of excess of electron. And at the same time, electron deficiency will be created at the second position of carbon in case of pyridine now. So the nucleophile, as it is showing the excess of electron, it is forming a bond with that carbon. Here you can represent single bond nucleophile. Then in the next resonating structure, what will happen? As the negative charge excess of electron is there on the nitrogen, it is forming a bond in between carbon and nitrogen. Here we are getting the double bond. We can see in the next resonating structure. And at the same time, here the double bond is present. That double bond, it is going to shift towards that carbon atom, and we are representing outside the ring negative charge, excess of electron. Then from this resonating structure, we are getting the another structure. How? See here, this particular negative charge which is present on the carbon, it is forming a bond inside the ring at this position. Here you can see that structure. Okay, and at the same time, here the double bond is there. One of the bond it is shifted towards the carbon, and we are representing outside the ring negative charge on that carbon. This resonating structure we are getting. Next, now you can see here the nucleophilic substitution in pyridine at the fourth position we will see. So this is the fourth position. Here you can represent one hydrogen outside the ring with the bond. Okay, and here what will happen, as you can see here the double bond, one of the bond it is shifted towards this carbon atom, and we are representing in the next structure excess of electron will be there on that carbon, so negative charge. We are adding the nucleophile. Now nucleophile, as it itself having a excess of electron, with the bond it is going to attach to the carbon atom which is present at the fourth position. Here you can see that is right. Okay, now from this we are getting the next resonating structure. How? Look at this very carefully. As the negative charge is present on this particular carbon atom, it is going inside the ring and forming a double bond over here. Then at the same time, here double bond is present. Now that bond, one of the bond it is going to shift on the nitrogen. So on the nitrogen you can represent a negative charge, excess of electron. This resonating structure we are getting. And from this resonating structure, we are getting the another structure. How? As the negative charge is present on the nitrogen, it is forming a bond in between nitrogen and carbon. And at the same time, here double bond is there. One of the bond it is shifted towards this carbon atom. Outside the ring, we are representing the negative charge. Okay, on that carbon. Rest of the things are as it is. So when the nucleophile attacks at second or fourth position in pyridine, more stable resonance structure is formed as intermediate, because negative charge is on the high electronegative nitrogen. Now we will see about the CHICHIBABIN reaction. Pyridine react with sodamide in liquid ammonia and gives 2-aminopyridine. The amination reaction of pyridine is called CHICHIBABIN reaction. See the reaction here, girls. As we are taking the pyridine, in that we are adding sodamide NaNH2, and the reaction will take place in the presence of liquid ammonia. Again, at the second position of the pyridine, this is the second position, represent one hydrogen outside the ring with bond. Okay, then what will happen? That hydrogen it is coming out from this side in place of that hydrogen from sodamide NaNH2, and H and A is going to attach with that bond, okay, in place of hydrogen. So that hydrogen, as it is coming out, reacting with one more hydrogen from sodamide, and we are getting the side product hydrogen gas. And this whole group NH and A is going to attach to the second position of pyridine. This is the intermediate compound we got here. So in this intermediate compound, we are adding water molecule. Then what will happen here? See, this Na is coming out from this side. Na is coming out. In place of that one hydrogen from water molecule is going to attach with NH. So we are getting here NH2. So it is named as what? 2-aminopyridine. Means at the second position of pyridine, amino group NH2 group is attached. So it is named as 2-aminopyridine. And as Na is coming out from this side, reacting with OH of the water molecule, and we are getting the side product as sodium hydroxide. Now we will see the mechanism. Step 1. As we are taking sodamide NaNH2, it is undergoing the ionization reaction, and we are getting Na plus ion and NH2 minus ion. In step 2, we are taking pyridine, okay. In the pyridine, Na plus NH2 minus, it is going to attach. How? We can see here, Na, it is being attached with the nitrogen of pyridine, and NH2, excess of electron will be there, here. Excess of electron with the NH2 group is there. So it is forming a bond with the second position of the carbon atom in pyridine. How it is forming a bond? As the double bond you can see here in between nitrogen and carbon, one of the bond it is shifted on the nitrogen. So here on the nitrogen in the next structure you can represent a negative charge. Okay girls, and NH2 being attached to the second position of pyridine. Now from this, what will happen? This particular hydrogen atom, above hydrogen atom, it is coming out along with the bond, along with the bond as H minus. And from this side, this hydrogen, it is coming out by leaving the bond here itself with the nitrogen, and that bond it is going to transfer, or it is going to shift in between carbon and nitrogen, and it is forming a double bond here. So H plus, H minus, and along with that we are getting that as they are combining, and we are getting the hydrogen gas as the side product. Then from this, in this particular intermediate compound, we are adding water molecule. So what will happen here, as we are adding the water molecule here in this, so what will happen? Look at this very carefully. Negative charge as it is present on the nitrogen atom. Okay, that negative charge it is being shifted in between nitrogen and carbon and forming a double bond here. Look at this. And at the same time, double bond is present in between carbon and nitrogen, isn't it? One of the bond it is shifted towards the nitrogen. Okay, negative charge on the nitrogen we can represent. So at that time what will happen? From the water molecule, H plus will come out reacting with NH minus, and we are getting NH2. Okay, so our main compound what we are getting here is 2-aminopyridine. At the second position of the pyridine, NH2 amino group is attached, and from this Na is coming out, Na plus reacting with OH minus of water molecule, and we are getting the side product as NaOH, that is sodium hydroxide. Alkylation and ARYLATION in pyridine, that we will see. Pyridine react with N-butyl lithium to form 2-butyl pyridine. See here the reaction. We are taking pyridine. See, as we are representing at the second position of pyridine, one hydrogen outside the ring, isn't it, with the bond. In that we are adding N-butyl lithium. So what will happen here? This hydrogen it is coming out from the pyridine reacting with lithium of butyl lithium, and we are getting the side product lithium hydride. Okay, and in place of hydrogen, butyl group is substituted here. So we are getting like this structure. It is named as 2-butyl pyridine. Means butyl group it is substituted at the second position of pyridine. It is named as 2-butyl pyridine. Next is the pyridine react with phenyl lithium to form 2-phenyl pyridine. As we are taking the pyridine here, represent here also, girls, one hydrogen at the second position of pyridine outside the ring. Okay, and in that we are adding phenyl lithium. So what will happen, that hydrogen which we are representing outside the ring in pyridine at the second position, hydrogen is coming out from this side, and from phenyl lithium, lithium is coming out, and we are getting the side product as lithium hydride. Then what will happen here, in the position, means at the position where second position of the pyridine, hydrogen is coming out now, in place of that one, this phenyl group, it is turning and attaching at the second position of the pyridine. So we are getting a 2-phenyl pyridine. Electrophilic reaction in pyridine. Pyridine has less electron density on the ring carbon. The electrophilic substitution reaction occurs in pyridine at third position under drastic condition. When electrophilic attack at second and fourth position, unstable resonance structures are formed. In this structure, positive charge is present on high electronegative nitrogen atom. While electrophile attacks at third position, the formed intermediate is more stable than the intermediates formed when electrophile attack at second or fourth position. You can see the reaction here. First of all, we are seeing the electrophilic substitution in pyridine at the second position. Second position, first of all, represent one hydrogen outside the ring with the bond. Okay. Now what will happen, as we are adding the electrophile in the pyridine at the second position. So what will happen, in between nitrogen and carbon double bond is there. One bond it is coming outside the ring to which electrophile is being attached. Like this we are getting. So as this bond is coming out, nitrogen is becoming electron deficient. So on nitrogen we are representing positive charge. To satisfy this position, what will happen in this structure? Double bond is present at this side. Now, one of the bond it is shifted in between carbon and nitrogen. Okay, so we are getting the double bond over here. You can see in the next structure. At the same time, what will happen? This position will become electron deficient. So to satisfy that position, this bond it is being shifted towards this side. So we are getting here double bond, and the positive charge will be created on this carbon atom. Next, what will happen? Another resonating structure will get how this double bond, it is being shifted towards this side to satisfy this position. So here double bond is forming. In the next structure, you can see double bond. And this position will become electron deficient. So we are writing here the positive charge on this particular structure. Okay. Again, if you want to satisfy this one, this bond is being shifted this side and the positive charge will be created on that side, means again we are getting back this previous resonating structure. Now we will see the electrophilic substitution at second position in pyridine. Second or the third, girls? Yes, third position of pyridine. See, the first position is where the nitrogen is present. Second position, this one. Third position, this one. We are talking about the third position or the fourth position. Third position, isn't it? So here at the third position in case of the pyridine, we are representing one hydrogen outside the ring with one bond. Okay. So now we are adding the electrophile in this. So what will happen? A double bond is present here. Now one of the bond it is coming outside the ring to which electrophile is being attached. At that time, this position will become electron deficient. Okay. To satisfy that position, one of the bond from this side is being shifted that side. So here we are representing in the next resonating structure here double bond, and this position will become electron deficient. Now to satisfy that position, one of the bond from this side is transferred to this side, isn't it? And forming a bond over here. You can see in the next structure double bond over here, and at the same time this position will become electron deficient, so the positive charge will be created on that carbon. Now we will see the electrophilic substitution in pyridine at the fourth position. Look at this, girls. At the fourth position, first of all, represent one hydrogen outside the ring, okay, with bond. In that, we are adding electrophile. Where the electrophile is going to attach, to whom it is going to attach. Here the double bond is present inside the ring, isn't it? One of the bond, it is coming outside the ring to which the electrophile is being attached. And at the same time, as this bond is going outside the ring, here this position carbon atom will become electron deficient. So the positive charge we are representing on that carbon. To satisfy that position, one of the bond from this side is going to shift towards that side. So nitrogen will become electron deficient at that time, representing the positive charge on nitrogen. Okay. Then from this we are getting the another resonating structure to satisfy the as the nitrogen is showing the electron deficiency. To satisfy this position, this bond is being shifted towards this side. So we are getting the double bond over here. You can see in the another structure. At the same time, this position will become electron deficient. So on this particular carbon atom, we are representing the positive charge. Now we'll see the example of electrophilic substitution in pyridine nitration. So here we are taking pyridine. In that we are adding nitric acid. The reaction will take place in the presence of sulfuric acid, and here we are maintaining the temperature 300 degrees centigrade. Look at the pyridine structure, girls. This position of pyridine is first position. We all know that. This is the second. Okay, this is the third. On the third position of pyridine represent one hydrogen outside the ring with the bond. Okay, that hydrogen will come out reacting with OH of nitric acid. OH of nitric acid. Okay, so we are getting the side product what? H2O. Here remains in the nitric acid NO2. In place of hydrogen at the third position, NO2 is substituted. So we are getting here NO2 at the third position. So it is named as 3-nitropyridine. Thank you for listening my lecture, guys.